Hello everyone and welcome in the 23rd lecture of our control system series. In last lecture, we discussed the concept of dominant pole. Now let us see some examples on dominant pole. Our first question is, a plant has a transfer function g of s is equals to 1 upon s plus 2 into s plus 14. And the question is, approximate the transfer function to a single pole. Now here we have two poles, s plus 2 and s plus 14, and they have asked to approximate the transfer function to a single pole. So any question based on the approximation of a transfer function is on the concept of dominant pole. So let us find the solution of this question. Now we have the transfer function g of s is 1 upon s plus 2 into s plus 14, and the poles are S1, the first pole, is at minus 2 and the second pole, S2, is at minus 14. Now we can plot this on the S plane. We have two poles, S is equals to minus 2 and S is equals to minus 14. And in previous lecture, we have discussed the concept of dominant pole, and it is the pole which is near to the origin is the dominant pole. So from these two poles, minus 14 and minus 2 is near to the origin. Hence, we can say the pole S1 is equals to minus 2 is a dominant pole, or it is a significant pole, and the pole S2, which is minus 14, is an insignificant pole. Now first, we need to check whether the criteria of a dominant pole is applicable or not, and we have the formula. It is the ratio of insignificant pole upon significant pole should be greater than or equal to 5, then only the concept of dominant pole is applicable. So we have the value of insignificant pole as 14 and the value of significant pole is 2. So 14 by 2 is 7 and 7 is greater than 5. Hence, the concept of a dominant pole is applicable, and therefore we can neglect the insignificant pole s plus 14 from the transfer function. Now, as told you in the earlier lectures, we cannot directly neglect the s plus 14, which is the insignificant pole, directly. First, we need to find the DC gain of the original transfer function. By substituting s is equals to 0 in the original transfer function, we can find the value of DC gain. So after substituting s is equals to 0, we will get 1 upon 0 plus 2 into 0 plus 14. It will be 1 upon 2 into 14. So the DC gain of the original transfer function is 1 upon 28. Hence, the DC gain of original transfer function is 1 upon 28. Now, after neglecting the insignificant pole, the transfer function becomes g of s is 1 upon s plus 2. Now, if you check the DC gain of our approximate transfer function, it is 1 by 2. If you put the value of s is equals to 0, you will get the DC gain 1 by 2. But our original DC gain is 1 by 28, and we have studied the DC gain of the approximated transfer function should be also equal to the DC gain of the original transfer function. So the approximate transfer function will be g of s is equals to, first write down 1 upon and then write down the significant pole or the dominant pole. Here it is s plus 2. Now if you substitute the value s is equals to 0, you will get the DC gain 1 upon 2, but we want DC gain 1 upon 28. So in order to get 1 upon 28, we need to multiply by 1 by 14. Now the DC gain of the approximated transfer function is the same, that is 1 by 28 as that of the original transfer function. So the correct answer for this question is g of s is equal to 1 upon 14 into s plus 2. We have approximated the original transfer function to a single pole as asked in the question. So this was one simple question on the concept dominant pole. Now we have seen this example where there are two poles. In next example, we will see what happens when we have three poles, then how to use the concept of dominant pole, and then we will discuss some questions asked in GATE and Engineering Services Examination. So I hope you have liked the video. So please like and subscribe to get more information on control system.